So this is number 6, and it's a little different than the previous example. I've taken the time to make a sketch of the function here, that is y equals 10t minus 1.86t squared, to see what it looks like. And it's a parabola, and this red graph over here on the right represents the height in meters of an object thrown on the planet Mars. And if you look to the discussion, every one of the average value calculations starts at 1 and then has a certain duration, like 1 to 2 or 1 to 1.5. In other words, every one of them involves a point that I've labeled P on the graph, and the location of that point is 8.14. And we're interested in what's called the instantaneous velocity of the object at point P. That is, we're looking for the slope. That's what an instantaneous velocity is when we have a position curve, and that's what we've got. The red curve is the position or height of the object at time t, and it starts from 0 down there at the bottom, and it finishes somewhere between 5 and 6. It's landing back. The graph does extend, but that's not really accurate, right? It doesn't have any meaning in physical reality. It starts from the ground or the dust, whatever we've got there on Mars. It is thrown up and it returns under the force of gravity just over 5 seconds later. So let's calculate some slopes of, not the tangent, because we can't do that because we've only know one point, but we can get some other points on the curve and calculate some secants. So let me bring up the calculator. I've reset the calculator, and I want to begin by going to the y equals key, and I want to clear out anything that I've got from before in y sub 1, and now I'm going to make it 10t. In my case, I'm going to have to say x for the calculator, and then I want to subtract from that 1.86 t squared. So I have to put x squared on the calculator. Now, I need to fix up y sub 2 because now my point has changed, my stationary point, my P, and so now I want to not say y sub 1 minus 0, I want to say y sub 1 minus 8.14. So I'm going to use my 8, and then I have to do an insert here, and I want to insert a point, of course, and I'm going to continue to insert 8.14, right? So now I've got the numerator set, and now I'll move over and I'll replace the 0.5 with a 1, and then I want to delete the 5. And I believe I have it all cleaned up now. So I'm ready to go to my table, and I'm going to put in some t values or x values and see what happens. So to get to the table, second table, right? And there's a lot of calculations there from before. You can just ignore them and just type right over. And our first value from Roman numeral 1 there is what's happening at 2. and what's happening at 1.5, and what's happening at 1.1, and what's happening at 1.01, closer to 1 itself, and 1.001. And although they don't ask for it, we can drive it closer, 1.0001, right? But, you know, if I put 1 in there, I'm going to get an error message, because although it can calculate the y, when I try to calculate the slope, now I have 1 minus 1 in the denominator, and of course that doesn't work. So I'm going to come up here. I'm going to visit over here on the right, and I can estimate the instantaneous velocity when t is 1 by that slope value of the secant when I got very, very, very close to 1. So let me take a picture of that and insert it. So to finish this off, I copied my display from my TI-83, and the answers to Part A, 1 through 5, are all there in the last column. And my estimate for instantaneous velocity when t equals 1, well, I copied down my extra. They didn't tell me how many places they wanted, but it is about 6.3. Hope this helps.